Alright, so let's talk about section 10.3, which is on translation and partial fractions. So let's first talk about translation by introducing a theorem. So if the Laplace transform of little f is big F, this is for s greater than c, then the Laplace transform of little f multiplied by e to the at is going to be big F shifted by a, and this is for s greater than c plus a. The proof of this is simple following the definition, so let's do it. So the Laplace transform of e to the at times f of t, by definition, is the integral from 0 to infinity of e to the negative s t times e to the at times f of t dt. And let's combine these two terms. So this is equal to integral from 0 to infinity e to the negative st plus at times f of t dt, and this is equal to 0 to infinity e to the negative s minus a t f of t dt. And by definition, this is literally equal to the capital F plugging s minus a. So that's the proof for the theorem. And this theorem is useful because now we can create a new chart for the Laplace transform. So let's do that. So let's recall we had a chart in the previous section. The Laplace transform of e to t to the n is n factorial over s to the n plus 1. This is for s greater than 0. And the Laplace transform of cosine kt is s over s squared plus k squared, also for s greater than 0. And Laplace transform for sine of kt is k over s squared plus k squared. This is also for s greater than 0. So this is an original chart. But since we just introduced the theorem, so we can do a translation. And we get a new chart. So the new chart has the same function on the left, except it's multiplied by e to the at. Then their Laplace transforms are going to be shifted by a, so it's going to be n factorial over s to the n plus 1, but now it's s minus a to the n plus 1. And then same thing for the other two, so it's s squared plus k squared. All these are shifted by a. And same thing for sine. And all these Laplace transforms converge for s greater than a. Right, so we're going to use this new chart to solve inverse Laplace transforms for rational functions.